Today we're going to be reviewing factoring, and we're going to be factoring 4 different cases. And we're also going to be talking about the zero product property, which we've touched upon, but we're really going to solidify our understanding of that today. So if a product is zero, product meaning multiplication, then one or more of the factors must be zero. We use the zero product property to help us find the x-intercepts of quadratic equations. So we are going to be factoring 4 examples and then solving for their solutions. So in our first example, we'll be using our box method. I will be putting my x squared and my 10 and thinking of multiples of 10. So 1 times 10 and 2 times 5. The only 2 of these that will add to 7 is 2 and 5. So we have 2x and 5x. I'm now going to factor each column and row. The greatest common factor is x. The greatest common factor is 2. The greatest common factor is x. And the greatest common factor is 5. So this means our factors for this quadratic are x plus 2 and x plus 5. Now I'm going to solve each one individually to find the zeros of the function, meaning the x-intercepts. I subtract by 2 using inverse operations, x equals -2. I subtract by 5, and x equals -5. Therefore, my zeros are -2 and 5, and my zeros, or my x-intercepts, are -2, 0, and -5, 0. In my second example, I'm going to be using a different method to solve. You'll see that we have an ax squared plus bx, but no c value. So this means we can't use the box method. We're now going to have to default to just the greatest common factor. So of -x squared and x, I know that I can pull out an x. And I'm going to pull out a -x just to make things a little easier. It doesn't matter if you do that or not. So -x times x would give me -x squared, and -x times -7 would give me -7x. Be very careful. Negative times a negative gives us a positive, so you want to make sure you make this negative. I'm now going to set both of these equal to 0 and solve. -x, we could make it a positive x by dividing by -1, giving us x equals 0 divided by -1. 0 divided by anything is always 0. And x equals 7. So this means that we have x-intercepts, or zeros, at 0, 0, which is the origin, and 7, 0. This is going to be a difference of 2 squares. This goes back to Unit 2. So a difference of 2 squares is when we have 2 perfect squares. So 25 is a perfect square, x squared is a perfect square, and 4 is a perfect square. This one's a little difficult because we have the negative in the front, and in the word problems that we're going to encounter, this will be pretty common to have. So we know that when it comes to a difference of 2 squares, we're going to have the same numbers twice, but we're going to change one of the values. So I know that I'm going to have a +5 and a -5, x and x, and then 2 and 2. So again, 25 broke down into -5 and 5, x squared broke down into x, and 4 broke down into 2 and 2. I'm going to set each of these equal to 0 and solve. Notice I made this positive because 2 negatives, when divided, make a positive. So this means that our x-intercepts, or our zeros, are 2/5 and -2/5. If this was a real-world application problem, it's more than likely that the positive 2/5 would be the correct answer, because most of the time we're talking about time, and in general we're not using negatives when it comes to that. In our last problem, we are going to be using the greatest common factor method again, and then using the box method. So I can factor a 16 out of 16, 16, and 480. So when I take 16 out, I'm going to take the -16 out, and this leaves me with t squared, because -16 times t squared gives me -16t squared. Now this is where you need to be careful. We want the result to be positive, so a negative times a negative is going to give us that positive. And again, a negative times a negative is going to give us this positive. And I'm going to use my calculator to figure out what 480 is divided by 16. And that gives me 30. So now we are going to factor this. So we have t squared and -30, and we want these numbers to add to -1. So the multiples of 30 are 1 and 30, 2 and 15, 3 and 10, and 5 and 6. The only two of these that could add or subtract to get to 1, -1, is 5 and 6. So we are going to use 5 and a -6 because we want them to add to -1. And then we're going to factor. Out of this column, we can factor out a t. Out of this column, we can factor out a -5, t, and -6, giving us 16, t minus 5, and t minus 6. Sorry, this should be a positive 5. So now we are going to set these equal to 0 and solve. So our x-intercepts / zeros of our function are -5, 0, and 6, 0. If this was a real-world problem, it's more than likely that the positive answer is going to be the correct answer, because in general with real-world problems we're not dealing with negatives.